Greetings and welcome, friends. Mr. Waddy here. Today we're talking about 7.3 special products of polynomials. Now, all of the problems I'm doing today can be done using the FOIL method or double distribution, but we need to know these special patterns because these patterns are going to be shortcuts for us, and eventually, later on, you will need to know how to use this shortcut backwards. Right? Not that I'd literally blindfold you and have you walk backwards through this shortcut, but you need to be able to use these patterns inside and out. So notice this. It says the diagram shows a square with side length a plus b, and a plus b because it's a square. Both sides are the same. You can see that the area of the square is a squared plus 2 of these ab terms plus b squared. Okay? And this is, in fact, a square outcome. So what's weird is the square of a binomial, a two-termed expression, ends up giving you an answer that in algebra tile language literally is a square. And that was somewhat by design, or this is an outcome of the design of even calling this square to begin with. So this is one version of a pattern called the square of a binomial. You guys will need to know this one. To find another version of this pattern, use algebra and replace b with the opposite of b. And notice that if you do so, you get the only difference between one pattern and another is that this one had a plus sign for your middle term, and this one had a minus sign for your middle term. So here we go. Square of a binomial pattern. A plus b all squared is equal to this. A minus b all squared is equal to that. I like to just memorize them as one thing because who has space in their brains for everything? And I just kind of think about this as plus or minus, and this would be plus or minus is the way I remember it. And as a quick example, right, we've got that. You guys can read those examples on your own later. We're going to do some examples ourselves, and I think that'll be more helpful. But one of the things I want to caution you of, something that I'll write on your paper, super illegal, is you will be tempted to try and distribute an exponent over addition or subtraction, which would be illegal. And what happens is you would actually end up missing your entire middle term. You would have had just the a squared and the b squared, and you would have been missing a middle term. In terms of what that looks like if I was doing an algebra tile type solution, if I just squared the a's and squared the b's, I would have gotten simply these two parts, and I would have been missing all of this for my square. So I just want you to realize that you cannot distribute an exponent over addition or subtraction. All right, so let's put this to work, and one of the ways we're going to do this, we're going to literally use this pattern where we have a and b, and we're going to label our values a and b. Yeah, and so we've just got to be familiar with the pattern, label our parts, and then plug in what we know. So here we go. I suspect this is the square of a binomial pattern because this is the square of a binomial. All right, so here we go. What I need to do first is label my A and B. I guess I'll label those in green. So A is going to be the 3x here, and B is going to be the 4. And the square of a binomial pattern, A plus or minus B, all squared is equal to A squared plus or minus 2AB plus B squared. And what I'm going to do is just simply plug in 3x for my a's and 4 for my b's and simplify. That's all I'm going to do. So plug in 3x for a, so I'd have 3x squared, and I've got to be careful. I need, by the way, these parentheses are mandatory, right? Just like Indiana Jones plugging in substitution property, right? You got to put your bag of, sand in a bag. Don't just throw your sand right in this equation. Put it in parentheses, right? Keep your sand together. If you don't have the parentheses, it would not appear to be in, you would misinterpret it because the square would only have applied to the x and not the 3 as well. Let's see. This is a plus sign, so I'm going to choose the version of this formula that's a plus sign. So plus 2 times a a is 3x, times b, which is 4, and plus b squared. And in this case, b is just a number, so I technically could get away without parentheses. But let's just get in the habit. All right, what I have done is I took the 3x and plugged it in for both of the a's, and I took the 4 and I'm plugging it in for both of those b's. This part? Because I already have that part over here, I'm now just finding out what is this equal to. And so since I already have this part, I only care about the right-hand side of that formula. I used this to just verify that it was the pattern, because I can't just do this whenever I want. I can only use it when the pattern applies, which is when I am squaring a binomial or multiplying a binomial by itself. And so let's keep simplifying. We'll practice this, don't you worry. So square both the 3 and the x, so that's 3 squared is 9 x squared, plus, notice this, 2 times 3 is 6, and 6 times 4 is 24. And I've got the x still hanging out there. And what is 4 squared equal to? Anybody, 4 squared? 4 times 4. No. It's alright. It's alright. Let's see. So there we go. So I figure out what a and b are. I plug them into the pattern, and then I simplify it. Let's see. So this 24x came from multiplying 2 times 3, and then times 4, and then times x. And the 4 squared is where the 16 came from. The 3x all squared is where the 9x squared came from. We'll practice some more of these, so your brain will create a pattern over time. Seeing it the first time is going to be tricky. So let's see. Let's move through this next one, and we'll try to get to a couple more as well. So let's see. A is going to equal 5x, and b is going to equal 2y. Right? I just swipe those right from there and there. And nope, you need to know all of these methods. So you do have to know this pattern. So this is a minus sign, so I'm going to use the minus version of the formula. Right? So let's see. A squared is now going to be 5x all squared. Minus, because of the minus sign, 2ab. So it's going to be 2. And instead of a, what am I writing? What did I call a moment ago? So instead of 2ab, what am I writing in for a? Yeah, so 5x, and then instead of b, I'm writing 2y, yep. And then it says plus b squared. So plus 2y all squared. So let's simplify this. I can distribute an exponent over multiplication, in case you didn't know that. Right, so both the 5 and the x are getting squared. No, I'm plugging in just the 2y, and the minus sign I took care of right here, because if this is a minus sign, then that's going to be a minus sign. You could call b equal to negative 2y if you're going to then use the plus version of the formula. And so it will work out if you use the plus version of the formula and then plug in a negative 2, but that actually gets a little bit complicated. Good question. I like that. So let's simplify this. 5 squared is 25, x squared is x squared, minus 2 times 5 is 10, and multiply that 10 by this 2, and I get 20. And then I've got x times y is just xy. I can't write that as x squared or y squared. X times y, those aren't the same thing, so they're just xy. And plus 2y squared, so 2 squared is 4. And y squared is y squared. So this is the idea. Label your A and B, plug them into the pattern, and simplify. Simplify. Let's see, let me do just 2 more of these. And then we'll have to move on to the other pattern. 2 patterns today. All right. First of all, question, does the pattern even apply? A plus or minus B all squared. This looks like that. Because it looks like that, I can use the pattern. All right. If it didn't, then I'd have to use double distribution or FOIL or something else. Okay. And this is equal to A squared plus or minus 2AB plus B squared. Not a bad idea to write the pattern down, again and again, just to get familiar with it. So let's label A and B. What does the A appear to be if I'm matching this to this part of the pattern? What's A is in the X slot, and B is 7. So I'm going to have A squared plus 2AB. Actually, am I going to use the plus or the minus version this time? This is a plus sign, so I'm going to use the plus version. Okay? So A squared would be X squared plus 2 times A. What am I plugging in for A? I'm plugging in X. And times B. What am I plugging in for B? 7. Plus B squared, so plus 7 squared. And now let's simplify. So that's X squared plus 2 times 7 is 14 times X plus 7 squared is 49. All right, so label A and B, plug them into the pattern, simplify. One last one. I'm going to do this quick. Don't write this next one down. Just follow along so you can just focus on the process rather than the writing. All right, so here we go. Does this match the pattern? Right? I've got a 2-termed expression, a binomial, being squared. So it matches the pattern. Tyler, what would the A be for this one? Yep. Let's see. Austin, what would you call the B for this pattern? 3. And if you did want to call it the -3, you can. Yeah. It's easier to call it the 3 and then just use the negative pattern, which is what I'll do. Yeah, you could try it both ways and see what happens. But yeah, B equals just the 3 is the easiest way to do it. And let's see. So A squared plus 2AB plus B squared. So A squared is now 7X all squared. Because this is a minus sign, I'm going to use the minus version of the pattern. So minus 2 times A is 7X times B, which is 3, plus B squared, so that's plus 3 squared. So label it, plug it in. And 7 squared is, I was just going to say 21, but that is not accurate. 49. X squared is X squared. Minus, let's see, 2 times 7 is 14. What's 14 times 3? Let's see, 3 times 10 would have been 30. 42, I think so. -42, and my only variable here is an X. And plus 3 squared is 9. Yeah. So this is the first pattern. Okay? The first pattern. The next pattern is actually even easier. It's called the sum and difference pattern. For obvious reasons. All right. It says find the product of x plus 2 times x minus 2. My friends in real life and I were talking about, are these the same thing? Not quite. Are they opposites? Not quite, right? If they were opposites, this would have had to be a negative x, and it isn't. These are called conjugates, all right, which your book right now is not telling you. Conjugates, when you have a plus b times a minus b. all right, or a sum and difference of the same numbers, the same terms, right? Sum and difference. It says if you do this, you can multiply the two binomials using the FOIL method, and whoop, 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 whoop. And when you do, you notice that the OI in FOIL, the OI, you end up with opposite terms. And we did this with algebra tiles earlier, and we realized that the OI in FOIL with those opposite terms, these would have canceled out, right? And we were left with like an angelfish pattern is what I called it. And so I'm left with just x squared minus 4. And because this will happen every time I have a sum and difference being multiplied, there's a pattern. And this is your sum and difference pattern. It's even easier than the last pattern. It's gonna be great, the sum and difference pattern. All right, here we go. Sum and difference pattern, a plus b times a minus b is equal to a squared minus b squared. All right, a squared minus b squared. So this one, I think, is easier to plug in. It's not as complicated. This is using a pattern instead of foiling or instead of double distributing. So all of our problems tonight are going to be pattern problems. They might be, but eventually you need to know how to do this backwards, and foiling backwards is actually a little bit difficult. I'll show you how to do it, though. Let's see. So I've got t plus 5 times t minus 5. My first question is, does this match a pattern? Yeah, right? It seems to match that. It's in that format. The sum and difference pattern. These weren't quite the same. They weren't quite opposites. They were conjugates. So since it matches this pattern, what would you have called the A? Representing A is T. And B, well, because these are plus or minus, I'll just look at the number and I'll just take the 5. You could call it -5. The pattern will still work. It's just you'll have to kind of do a little bit of extra thinking. And so I'm going to take A and B, and now since it matched the pattern, right, I can plug it into a squared minus b squared. So that's going to look like t squared minus 5 squared. And so t squared is t squared minus 5 squared is 25. My 2 there almost looks like a greater than or equal to sign. It's kind of weird. All right, let's do one more example, and then we'll say bye to our internet friends, and we'll have you guys do a class quest for the last bit. All right, does this match a pattern? Yeah. Because it's the sum and difference of the same exact things, right? These are conjugates. So therefore, what would we have called A? 3x. And let's see, someone else, what would we call B here? Well, let's see, what's in the A slot was the first term for each of those. We called 3x. So B is just going to be the y. Boy. Yeah. And let's see, plug it into the pattern. The pattern is a squared minus b squared. So I'm going to have 3x instead of a, all squared, minus y squared. And 3 squared is 9. X squared is x squared. Minus y squared is y squared. And I use the pattern. And eventually, once you're really, really good with this pattern, you'll be able to like just spot these a mile away, and you'll be so fast. But right now, I need you to show your work, and this is what your work looks like. Label A and B, plug it in, and then simplify. All right? So thanks for watching, internet friends. Have a great day.